Today talk law of thermal radiation, course applied physics. My name is K. Vinay Kumar Reddy from ITB section. Introduction to thermal radiation. Thermal radiation is the essence of law of electromagnetic waves from all matters with a temperature above solution zero. It is a key emission of heat transform and occurs without the near for the medium. Understanding the thermal radiation is essential for the applications in the physics, engineering, and climate science. Basic of electromagnetic radiation. Electromagnetic radiation including as range of wavelengths from radio waves to gamma rays. Thermal energy radiation primarily falls within the in range of spectrum. The intensity of wave and wavelength of intimate radiation depends on the temperature of the emitting body. Steinbeck Boltzmann's law. Stephen Boltzmann's law statements that the power radiation by a black body is proportional to the fourth power of its absolute temperature. Mathematically, it is expressed as P equal to sigma A T into 4, where is the Stephen Boltzmann constant. This law sequentially have to thermal radiation increase dramatically with the temperature. Widely displacement law. Widen displacement law describes the relationship between the temperature of the black body and the peak wavelength of emitted radiation. It states that the wavelength of a maximum emissions is invariantly proportional to the temperature. Mathematically, it is expressed as lambda max equal to flexibility, where V is the displacement context. Black bodies and ideal emitters. The black body is the ideal physical objective that the abstract all including electromagnetic radiation. It is always a performance imitations of thermal radiation, meaning it is emits radiation at the maximum possible intensity for its temperature. Real world object approximate blackboard in behaviors but may reflect or transmission some radiation. Gray bodies and real emitters. Gray bodies are real words objects that emit less radiation than the performance blackboard at the same temperature. The emissivity of the gray body is a context across all wavelengths ranging from 0 to 1. This property is crucial in calculating the thermal radiation for real material. Emittive and its potence essentially is measuring of the how effective as surface emission rate thermal radiation compared to the blackboard. It is a dimensionless quality that the various with the wavelength and the surface continuation of a material. Knowledge of a emittive is essential in thermal management and the energy effective applications. Kirchhoff law of thermal radiation. Kirchhoff law statement that the thermal equilibrium that Sensitivity of the body equals its abstract at the given wavelength. This law underpins the concept of the thermal radiation and its interaction with matter. It emphasized the balance between abstraction and the emissions in a thermal process. Higgs law of a black body radiation. Higgs law describes that the specified defined as the electromagnetic radiation emission black body in thermal equilibrium. It provides of a formula that is incorporates both temperature and the wavelength to provide emission. This law is fundamental in understanding how different bodies radiation energy at the various temperature. Applications in engineering. Thermal radiation practicals are applied in this significant hot discharge at the thermal ensure engineers used sensitive value of optimizing materials from the energy efficiency in building and applications. Understanding thermal radiation helps in the thermal management of a electronic device and system. Roles in cinematic science. Thermal radiation plays a crucial role in the Earth energy balance and the climate system. The greenhouse effect in the influenced by the obstructions and emissions of the thermal radiation by gassing in the atmosphere. Climate models expression thermal radiation to the prediction temperature changes and weather patterns. Thermal radiation in space. In the space, thermal radiation is the premium means of the hot transfer as there is no air or medium. Space creates and stabilized much manage thermal radiation to the maintain thermal temperature. Understanding thermal radiation is key to distance effective and thermal context and aerospace applications. Measuring thermal radiation. Various institutions such as thermometers and radiometers are used to measure thermal radiation. This device can be determination temperature and emission by analyzing material radiation. Challenges in future direction. Accurate modeling of a temperature radiation remains a challenge due to complex material property. Future research aim to improve their materials in various distributions. Conclusion. The law of thermal radiations are fundamental to understanding heat transfer in a physics and engineering from the Stephen Boltzmann law to Planck law. These principles have applications across multi fields. Thank you.